Section 4.3 Logarithm functions. Consider the exponential function f of x equal to a to the power of x. From the previous sessions, we know how to graph these exponential functions. And like all the exponential functions, f is 1 to 1. When the function is 1 to 1 function, we should be able to find the inverse function. Okay, how about this guy? Remember how to find the inverse function? First step, we're gonna replace the f of x equal to y. Okay, and then interchange x and y. So we're gonna have x equal to a to the power of y. Next step, solve for the y here. But y is the exponent. How can we solve for it? We don't know how to solve the y, but we're supposed to have a y equal to something in terms of your x, and then that will be our inverse function, right? And what is a y in here? Think about it. Y will be the exponent to which we must raise a to get the x. Okay, one more time. Y will be the exponent to which we must raise a to get the x in here. That's your y. Okay, so this is also the inverse function. So here, y is the exponent to which a must be raised in order to obtain x. And we call this exponent a logarithm, symbolized by the abbreviation log. The expression, the log with the base a of x, will present the logarithm in this discussion. So we're gonna introduce a log. Okay, we're gonna use the log to solve for the y from this equation here. When we have x equal to a to the power of y, what we're gonna do? We're gonna take the log both sides. Okay, just similar the idea with we're gonna take the square for both sides. Okay, we're gonna take the log both sides here. And then, since the y is with the exponent of a, for the exponent, we could put it in the front. Okay, this means y times log of a here. Okay, one more time. Y will be the exponent. So we could put it in the front here. Become y times log of a. And then we're going to divide it by the log a for both sides. Okay, so this is what we saw for your y. And then last step, log of x over log of a. We could rewrite it to the log with the base a of x. Okay, one more time. When you have a log x over log a, you could put the a in here. This means the log with the base a of x. Okay, you can say this is a log with the base a of x, or log of x with the base a, or base a log of x. That's the same idea. Okay, so now we solve for the y here, and this is gonna be the inverse function of this equation. Okay, for all real numbers y and all positive number a and x, where a cannot be equal to 1, if we have y equal to log base a of x, if and only if x equal to a to the power of y. I want you guys to highlight this one. Okay, you need to remember this formula. When you have an x equal to a to the power of y, the exponential function, then you could rewrite it as y equal to log base a of x. Okay, let's try to do this example. Writing equivalent log and exponential forms. Complete the missing equivalent forms in the table. So highlight this guy. That will be the formula. You need to use it for this example. So this one, they is given the exponential form. We have a 3 to the power of 4 equal to 81. So your 3 will be your a here. Y will be equal to 4, and x, that will be equal to 81. So we're gonna plug into this formula. So y, that will be your 4, right? Equal to log the base a will be the 3 here. 3 log with the base 3 of 81. that will be equal to 4. Okay, I want you guys try. Second one, they given the log form here, and I want you guys write it with the exponential form. Okay, try your work. This one, you have the a is going to be 1/2, x will be the 8, and y equal to -3. Okay, so that will be 8 equal to 1/2 to the power of -3. And this one, your a will be equal to 10, your y will be equal to 3. X will be equal to 1000, plug it in. Okay, this guy, your a will be equal to 5, right? So 5 to the power of -3, that will be equal to 1/125. Okay, last two here. Log 12, log base of 12 equal to 1, okay? And this guy, 6 to the power of 0 is going to be equal to 1. Okay, right? You guys need to know how to write the exponential form and with the log form using this formula. Okay, now solve each equation. Same idea, we'll be using these two formula. When we have the log here, you want to rewrite it to the exponential equation. Okay, so your a will become your x here. So that will be x to the power of -2 equal to 16/9. Okay, x to the power of -2. Since this is a negative, you could like rewrite to 1/x squared, or you could flip this guy. And then we have the square. We're gonna take the square root for both sides. When we take the square root, we're supposed to have a plus minus here. But since the log here, we only can have positive real numbers, so we reject the negative. So that will be 3/4. Okay, this one. Write it to the exponential form. So that will be 16 to the power of 3/4 equal to x. Okay, simplify it. 16 to the root. This is the fourth root of 16, right? So that will be equal to 2. So 2 to the power of 3, that will be equal to 8. Okay, last one. Okay, they have the x for the exponent. So we try to write the same base here. So 36 to the power of x, we could write to 6 squared to the power of x. And this is just 6 to the power of 1/2. Okay, we could multiply the exponent. Now they do have the same base, so we could write it down. 2x equal to 1/2 here. Divided by 2 for both sides, so x equal to 1/4. Okay, if a greater than 0, a not equal to 1, and x strictly greater than 0, then the log function with the base a is this guy. Okay, make sure it has to be positive number, the a and the x. Now we try to find an inverse function. Remember, this is exponential function, and we already know this is going to be the one-to-one function. Okay, so first step, we're going to replace the f of x equal to y. And then interchange the x and y. Okay, take the log for both sides. And then remember the y, that's the exponent. You could put it in the front here. Divided by log 2 for both sides. And then we could rewrite this guy, that will become log with the base 2 of x. And this is going to be the inverse function of f of x. Okay, so we know how to find the inverse function. Now we want to graph the inverse function. So f of x, this is the exponential function. Remember, we graph it like this one. Pass through the points 0 and 1, right? And y equal to 0, that will be the horizontal asymptote, right? The curve is only approaching to the x-axis, but not touching it or intercept. And then the inverse function will be the refraction of the line y equal to x. Okay, y equal to x. Imagine this is just a mirror, right? You put the mirror, you're gonna copy the exponential functions like here. That's a refraction. And this is gonna be the inverse function. Okay, look at the domain here. The domain for this guy will be from 0 to positive infinity. The range will be from negative infinity to positive infinity. Remember from the session 4.1, we talked about it. This is going to be the domain, right? The domain of fx will become the range of the inverse function. So you could see negative infinity to positive infinity. That will be the range of the inverse function. And then the range of the f of x will become the domain of the inverse function. For any exponential function, the inverse is called a log function, base a, and is written as the form log with the base a of x. The graph of the inverse can be drawn by refracting the graph of f of x equal to a to the power of x across the line y equal to x. Okay, one more time. That will be the inverse function reflected by the line y equal to x. So now you're going to remember exponential function and then the log function, they are the inverse of function of each other. And keep in mind that the domain of the exponential function is the set of all real values. So the range of the log function also will be the set of the real values. Remember, the domain of f of x will be the range of the log function. And then another way around. So the range of the exponential function will be the domain of the log function. And then the log can be found for positive numbers only. We never have the negative number for the log. Okay, this one. We know how to graph the log function already, but I want you guys try to use this table. Plug in the x here and then find out what is the y. Okay, let's do it together, this one. Okay, so first one, we're gonna plug in x equal to 1. So we have f of 1 equal to log 3, 1. Okay, that will be equal to 0. You could try to use with your calculator. Okay, I'm gonna show you guys the formula here. So when we have a log with the base a 1, that would be equal to 0. When we have the log base a with the 10, this is gonna be equal to 1 because we have a 1 0 here. Or when we have a log with the base a 100, that will be equal to 2. This because this is a 2 0 here. Okay, Same idea when you have a log with the base A of 1000, that will be equal to 3. Okay, so this is going to be equal to 0. Second one, when we have a log 3, log with the base 3 equal to 3, that will be equal to 1. Okay, that's another formula here. If they have the same thing, A and A, that is going to be equal to 1. Okay, when they have the same base with the x here, that will be equal to 1. So this guy is going to be equal to 1. Okay, 1/3. So f of 1/3 equal to log the base 3, and then we have the 1/3 here. I'm gonna show you guys some step here. 1/3, I could rewrite it to 3 to the power of -1. Right? That's the exponent. And then remember, at the beginning, we talk about that when you have R. Okay, log with the base A of x to the power of R. R will be the exponent. That would be equal to, we could put the R in front of the log. So log A. So we have R times log with the base A of x. Okay, put it in the front here. So same idea with this guy. We have a -1, so we could put it in the front. -1 log 3 and 3. So not 3, 3, that will be using this formula. Log base A of A equal to 1. So that will be equal to -1. Okay, so this guy, that will be equal to -1. And then another one, f of 9, log with the base 3 of 9. And then the 9, I could rewrite to 3 square. And then the 2, we're going to put it in the front. 2 log base 3 with 3. And this guy, again, one more time, log AA, that will be equal to 1. So 2 times 1, which is going to be equal to 2. Okay, right? Okay, now you guys should be able to do the rest of it, right? This is gonna be f 1/9. The 1/9, same idea with this guy. That will become 9 to the power of -1. Or you could rewrite it to 3 squared to the power of -1. You should get -2. Last one, 27. So 27, we could rewrite it to 3 to the power of 3. And then the 3, put it in the front. So that will be equal to 3 here. Okay, so we do have all these ordered pairs. We're gonna graph it one by one. Okay, join it all together. You can see the curve is gonna be approaching to the y-axis, right? That's why x equal to 0, that will be the vertical asymptote. Okay, x equal to 0, that will be the vertical asymptote. Okay, try. Write it down. What is your domain, the range? What is the vertical asymptote? And then for this graph, it's gonna be increasing or decreasing. Okay. For the domain, that will be from 0 to positive infinity. Range will be from -infinity to positive infinity. Vertical asymptote, that will be this equation, right? Y-axis, that's called x equal to 0. And then f of x is gonna be increasing and continuous, okay, and continuous. The graph passes through the points, okay, you could pick any of here, okay, I just highlight these 3 points. They pass through these 3 points. Okay, how about this one? This is a log with the base a of x, and then a is gonna be greater than 1 here. Okay, think about it. What's the domain, the range, and the vertical asymptote? Domain will be from 0 to positive infinity. Range, negative infinity to positive infinity. Vertical asymptote, that will be x equal to 0. And again, this is going to be increasing and continuous. So the graph passes through the points. Okay, you're going to be passing through these 3 points. Okay, when you have the base a, you have a 1 over a, negative 1, 1, 0, and a 1. Okay, that will be similar to this guy. 1/3, negative 1, 1, 0, and 3, 1. Okay, same thing. Now try to graph the f of x equal to log with the base 1/2 of x. And you know this is going to be the inverse function, right? So first one, I do have a log with the base a, 1. Remember what's going to be equal to? That's going to be equal to 0. Second one, remember log a, these two numbers are the same thing. So that will be equal to 1 here. And then the 2, let me show you guys for this one. Okay, we have a f of 2 equal to log 1/2 and 2. So I could write it down log 2 over log 1/2. Okay, we could make like the base become this guy, log 2 over log 1/2. And then log 2 over log 2 to the power of negative 1. Okay, log 2 over the negative 1 is exponents, so I could put it in the front. Okay, cancel out. That will be equal to 1 over negative 1, which is going to be negative 1 here. Okay, that's the same idea. And then the 4, same idea, you're going to get negative 2. Try to work on it like the previous one here. And then last one. Okay, right? This time, the f of x is going to be decreasing. Okay, because this is going to be 1/2. The a will be in between 0 and 1. Okay, that will be going decreasing. When we have the a is going to be greater than 1, that will be increasing. Okay. So the domain, same thing, from 0 to positive infinity. Range, all real values. Vertical asymptote, we still have the y-axis, x equal to 0. And then for this function, this is going to be decreasing and continuous. Graph pass through the points. I just picked these 3 points. Okay, right? When you graph these two functions, this is the inverse, right? The log of base 1/2 of x, and this is going to be y equal to 1/2 to the power of x. Okay, they are inverse of the function. So it's going to be reflected by the line of y equal to x. Graph each function, give the domain, range, and the asymptote. Okay, so we know how to graph of f of x equal to log base 3 of x. Right now, we're going to put x plus 2. Remember the transformation of graph? When you have x plus 2, you're going to shift to the left 2 units. Okay, so the whole graph is going to be shifted to the left 2 units. And before that, when we have a log base 3 of x, x equal to 0, that would be the vertical asymptote. Now we're gonna shift 2 units to the left. So that will become x equal to -2. That would be the vertical asymptote. And then the domain, since we shift the whole graph to the left 2 units, so the domain becomes from -2 to positive infinity. The range, same thing, all real values. Vertical asymptote, x equal to -2. Okay, try one more. This time we have a f of x log with base 4 of x plus 2, the whole equation plus 2. So what you're gonna do? You're gonna shift upward 2 units. Okay, upward 2 units. So domain and range doesn't change. Vertical asymptote doesn't change either, right? Because we only shift upward. Okay, this one, we're gonna do x minus 3. So we're gonna shift to the right 3 unit and then plus 2. So to the right 3 unit and then go up 2 unit. So the domain become from 3 to positive infinity. Range, all real values. Vertical asymptote, that will be x equal to 3. Properties of log. The properties of log enable us to change the form of log statements so that products can be converted to sum, quotient can be converted to the difference, and powers can be converted to the products. Okay? So this is the formula. I need you guys highlight it and memorize it. Okay? X greater than 0, y greater than 0, a also greater than 0. And a cannot be equal to 1, okay? So we do have the product property when you have a log a x times y. Okay, log with the base a of x times y. You could rewrite it to log a x plus log a y. Okay, you could break it down. When there's a multiplier, you could add it up together. Keep the base of a here. When it's a quotient, when x divided by y, you do have a log with the base ax minus log base a of y. Okay, product will be addition. Quotient will be the subtraction. And then we talk about this guy already, the power property. When you have the exponent r, you could put it in the front. Okay, so r times log with the base a of x. And then log a1 equal to 0, log a equal to 1. We talk about these 3 guys already. So only these 2 formula. Okay, try to use the formula and then rewrite each expressions. So we have a log base 7 x times 6. Okay, this is the product. So you could break it down with the log with the same base 7 x plus log 7 x 6. Second one, this is the quotient, right? So it's going to be log 6 12 minus log 6 5. This guy, we have the cube root of 9, okay? So we could write it as exponent. That will be 9 to the power of 1/3. And then the 1/3, you could put it in the front. Okay, this one, we do have the product and also the quotient. Let's take care of it one by one. Okay, we're gonna have r s squared t minus, because of the quotient, u to the power 3 and v to the power 5. And then now we're going to apply the properties again. This is going to be log b r plus log b s squared plus log b t minus the same thing, log b u cubed plus log b v fifth. Okay, make sure you put the parenthesis here. And then now we're gonna take care of the exponents also. The 2, you could put it in the front. The 3, you're gonna put it in the front here, and 5 also. Make sure you distribute the negative. Okay, negative and negative in here, okay? Okay, one more. We write this exponent, so that would be 3 over 5. And then put it in the front for the exponent. Okay, this is gonna be the mth root, so that will be 1 over m for the whole thing. And then the exponent, we could put it in the front here. Okay, now we're gonna take care of it one by one. So this is gonna be r cubed s squared minus log a t over 4. And then this guy, log ab, will become log a plus log b, right? At the end, take care of the exponent. Okay. Okay, now, for this expression, we want to write it as a single log with the coefficient 1. Okay, single log. So we want to combine it together. Okay, the previous example, we're going to expand it. This time, we're going to combine it. Okay, this one, we could switch the order for this two. So that will become log 4x plus log 4z. So that will be x times z here. And then minus, that will be the quotient divided by the y. Okay, all of them has the same base. B, try to put the coefficient become the exponent. So that will be log b all to the power of 4th minus log b s to the power of 5th. And then subtraction, so it's going to be divided. Okay, combine it into one single log. Same idea for this guy. Put the exponent to the front first. And then we're going to combine it, add it up, so you multiply these two guys together, and then divide it by x and y. And then keep in mind that when we have log base 3, parenthesis x plus 2, you don't distribute it. Okay, you never distribute the log with this guy. Okay, they are not equal to each other. And then we consider x plus 2 will be the one term. You don't distribute the log base of 3 here, okay? Assume that log base of 10 of 7 equal to 0.8451, okay? And then find each log. So this is a 79. We could rewrite it to 7 square. And then the square, we could put it in the front. And then we already know what is a log base 10 of 7, right? That will be equal to this guy. So plug it in. Okay, this one. Log base of 10, 70 equal to, I break it down 70 to 7 times 10. Because we know about the 7 here, right? And then this is like log a x times y. So become log a x plus log a y here. This guy, we already know that's equal to 0.8451. And remember what's log 1010? Remember what's log base a with the a? That would be equal to 1, okay? Okay, film on inverse. For a strictly greater than 0 and not equal to 1, the following properties hold. When we have a to the power of log ax equal to x, and log ax, that will be equal to x. Okay, this guy, you could put it in the front, right? The x is going to be put in the front. Log that will be equal to 1, and that's why they're equal to x in here. Okay, this one you could use it as a formula. Okay, when you have a to the power of log ax, that will be equal to x. Just like this guy, 7 log base 7 of 10, that's equal to 10. And this one, log 5 to the power of 3 equal to 3. And this is a log base of r. The k plus 1, that's the exponent, so you could put it in the front. The second statement in the film will be useful when we solve other log and exponential equations. That's it.